now? Okay. So good afternoon, everybody. So today, I told you last time I'm thinking to start chapter 4 before we finish chapter 3, but I don't think we need to do that because we are very close to finish chapter 3. So let's finish it first. So what I did last time, guys, I told you last time I started to explain how can we program push buttons. I told you we have oops, sorry. Yeah, we have 4 push buttons here, guys. These 4 push buttons are connected to port H, pin 0, 0 to 4. Okay, so if you, yeah, just let me go back to here. Yeah, here. Okay, guys. So we have 4 of them. As we see here, it's written BH0, BH1, BH2, BH3. So these ones are connected to the first 4 pins on port H, right? This is similar to the first 4 switches, by the way. Okay, that's why I told you last time that usually you have to use one of them, either a switch or as a push button. Okay, and yeah. So actually, as you see here in this figure, here this one is 5 volt is here, and this is okay. Let me, can I make it better? So here, this is like, this is the push button, and this is the switch. This one is actually 5 volt, and this is PH0 to PH3. Is that okay? So what I'm saying is that if you wanna use a push button, you have to make sure that the switch is open. This is very serious, okay? Otherwise, maybe if you don't pay attention to this, you may waste too much time, because you look at your program, everything looks okay in your program, but it's not working, right? Yes, because the problem is not in the code, right? The problem, if this one is connected, if the switch is connected, so always we are gonna get 0 volt here, no matter what. Okay, if you press or you don't press the push button, always we are gonna get 0 volt here. Okay, we don't want to do that for sure. What we want to do is so if you want to use the push button, you have to make sure this one is open, as I told you, so that when you press, you are going to get a 0 here, because you actually are going to make a short circuit this way. You are going to get a 0. If you release, so it should be something like that, guys. It's 5 volt all the time. Once you press, it's going to be 0, and then once you release, you go up again. It should be something like that. Okay. So I explained that last time here. Yeah. I told you that's what I'm explaining. It has to be something like that. However, in reality, in case of mechanical switches, okay, because in mechanical switches we have a spring, so there is a spring, right? So what happens when you connect or you disconnect, it's not gonna connect right away. So the spring is gonna make some vibration, disconnect, connect to disconnect. So actually you are not gonna see something like that here. Okay, when you press or you release, you're not gonna see, but you are gonna see bouncing. That's why this is called bouncing problem, right? So also you're going to see bouncing here. It's going to bounce before, this is going to bounce before it connects. This one is going to bounce for little bit time. Maybe 20 milliseconds, it is too much. Usually it's less than 20 milliseconds, but you can measure it anyway. So here, and I told you what is the problem here. The problem is that if you, because your computer is very fast, okay, what's going to happen, your program is going to consider this is one press, second press, okay, and so on. So you, all of this should be counted as only one press or one keystroke, right? So if you want to, that's what I explained last time, if you want to shift the LED one time, every time I press I want to shift it one time, okay, so all of this has to do it only one time, okay. However, because of this bouncing, the computer is going to come here, is going to think, the microcontroller is going to think this is one press, another press, a third press, and so on. So you press one time, but you will see the computer is going to the microcontroller is going to react as if you pressed it 3-4 times. Is that okay? So this is called the bouncing problem. This problem is in all mechanical switches. And I told you also last time, in order to solve this problem, we have 2 solutions. One solution, we call it hardware solution. I just give you one idea here for hardware solution. In hardware solution, I can put a capacitor this way. You know why I put capacitor here? Simply because as you see here, guys, can you see the voltage is going to increase a little bit, because think about it. It's connected, disconnected, connected, disconnected for a very little time. So what's going to happen here, once you come here and then go up again, so here you start to charge, right? But because this is the main point, because the bouncing happens very fast, right? So this one is not going to charge too much. Okay, so the voltage is not going to increase too much. Yes, you increase the voltage little bit, but still it's going to be counted as zero, logic zero, right? So it doesn't, so it's not going to have any impact. As I told you before, in order to be considered as logic zero, it has to be in a range. For example, from 0 to 0.00 volt. So if the volt increased a little bit because of the ripple, so it's not a problem. So what happens here, as I told you, the capacitor should charge when it goes too high. Once it goes too low, right? Low means it's connected, the switch is connected, right? So it discharges, So anyway, this is what we call hardware solution. So we can handle the problem this way. Also, we can do it another way, what we call software solution, okay? So I told you here, we can write this code, this one, and then this one, and this one. And let me tell you what is the logic here. The logic is, look here, guys. Once this button becomes low, okay, so number one, I'm gonna wait 20 milliseconds, because just I want to bypass this bouncing period, okay? So I just want to bypass it, okay? And then I'm gonna wait until you release here, as you see here, guys. So I'm gonna say, as long as this pin is 0, keep looping. So I'm gonna keep looping here. I'm gonna wait until you release. Once you release, so I'm gonna come here. Here also, I'm gonna wait 20 milliseconds just to bypass this period. So by this way, if I use this code, when you press one time, your program is gonna act one time. Okay. Also, I give you this program last time. Maybe that's the reason I'm just repeating it, because I wanna, first of all, I wanna build on what I did last time. Also, because I did it very quickly at the end of the lecture. So anyway, so here I explain how can you shift LED. So the idea here, I told you in the beginning, when LED should be on. When you press one time, so I'm gonna shift it. So this one is on. When you press one time, this one is on until at the end. After the end, you are gonna bring it back. You go back to the beginning again after you push all the way to the end. Okay. So how can we do that? As you see here, guys, this part is just, the first part here is just initialization, right? This is just very easy. Look here, look what I did here. Look at this instruction here, guys. So here I'm gonna branch as long as it is set, as long as it is high, keep branching, right? So I'm gonna wait until you press. That means here, yeah. So here, as long as you don't press, I'm not gonna take any action. I'm gonna wait until you press, okay? Once you press, so I'm gonna come here. I'm not gonna keep looping. I'm gonna come here. Once I come here, so this code for deep bouncing, that's what I told you about. We call it deep bouncing. You know, in English, when you use D means you cancel, okay, canceling the bouncing. Yes. So this is what we call deep bouncing. So this part is just for deep bouncing, right? And then here I'm gonna shift to port B. So I'm gonna shift the value of port B. And then if the result is not 0, okay, so I'm gonna come here to branch back to the beginning again. However, if the result is 0, 0 means, you know, when 0 happens when you push it all the way to the end, right? So now it is 0, 0, 0, 0. So I told you, once it is 0, 0, 0, I have to bring it back to here, right? And that's what I did. Look here. Look here, guys. So here, as long as it is not 0, I'm gonna come to here. But if it is 0, I'm gonna come to here in order to write one here to the beginning again. Also, I told you last time, look here. Someone can ask me, "Yeah, that's too weird. You told us before, most of the time you have to use compare before any branch instruction." That's true. Okay, but if this is true, why you are not using compare here? Okay, who's gonna set the flags? Okay, I'm gonna tell you my answer here. My answer is, number one, if you want to use compare, it's totally fine. You can just put compare here. If you want to use it, you can put like some instruction for compare here. That's totally fine. You can compare to 0, right? But actually, you don't need it. You know why? I'm gonna tell you why. Because branch if not equal, this one is gonna look at the 0 flag. Is that okay? So this one only cares about the 0 flag. So if this shift instruction is gonna set or clear the zero flag, so I don't need to compare, right? That means if the result after I shift, if the result is zero, okay, this instruction is gonna set the zero flag. That's exactly what compare is doing. So I don't need to compare. You got what I'm saying? Anyway, again, I always tell my students, I'm not asking you to make it like make it simple. As long as it is simple and correct, much better than making something fancy or something more advanced and with errors, right? So again, if you want to use compare here, I don't have any problem at all, but also you should understand in some cases you may not need it. But if you're not sure, you can just use compare here. It's not going to make a difference. Okay. So this is a program. I displayed also the video last time. Now I also have here another program I'm going to teach here also about using the push buttons. Yeah, here. Do you remember, guys, when I in the alarm, I displayed a program before. I explained this program. This is the alarm. This is the police alarm. I used the switch. In order to turn the alarm on and off. Okay, so let me just remind you, because I want to tell you what is the difference between this one and what I'm going to explain right now. Okay, so yeah, let me share. I'm not sure if I'm sharing the computer. Share computer sound. Okay.
Look here, the siren is working.
The siren is
It's
working. Look.
now it's off.
So
So
here,
here,
so I explained this program before, guys. How can you use one switch to turn the siren on and off? Is that okay? That's what I explained before. Now I wanna make the same thing, but using the push button instead of a switch, right? Is that the same way? No, not necessary. I'm gonna tell you why it is different. Okay, so let's first show you how I did it, because you should understand the nature of a switch and a push button. Okay, in case of a switch, just to give me 1 second to clarify this point. Okay, in case of a switch, guys, if you open the switch, so it's gonna be high. Once you connect the switch, it's gonna be zero. Okay, all the time it's gonna continue zero. Once you put the switch in the other position, so I have two position. In one position, it's gonna give you 5 volt all the time. In the other position, it's gonna give you 0 volt all the time, right? So here it's very simple. If I wanna know if you want to turn the switch on or off. So now I have two position, guys. One position for the switch. So for example, I have a switch this way. If you put the switch up, for example, so you are going to get 5 volt. If you put it down, you are going to get like 0 volt. Is that okay? This is how switches work. Okay. So I can assume one of the position for on and one of the position for off. Okay. And now if I want to know if I should run the code or not, all what I have to do is I have to check the value of pH, the port H, and then to see if it is connected or disconnected, right? So here, for example, if it is here in this example, as you see here in this example, I'm gonna say if it is zero, keep looping. So zero means it's off, as you see here, right? So as long as it is zero, I'm gonna keep looping here. I'm not gonna come to run this part. So it's off, right? So here I'm going to consider this is off, and then I'm going to consider this is on, right? So here, if you want to use the switch for on off, it was simple, it was easy, right? Why it was simple and straightforward and easy? Why? Because very easy, just to go to the pin, okay, just to check the value of the pin. If it is 5 volt, it means it is on. If it is 0 volt, it means it is off. That's it. And then take your action if it is off or on. Is that okay, guys? This is in case of a switch, right? However, the story is different in case of push button. And your code also has to be different. Okay, why the story is different? I'm going to tell you why it is different. Because, for example, in the beginning, I'm going to assume the switch is off. I'm going to consider the case is off. Once you press one time, it's gonna return back high. So at this time, it's me because you press one time, I have to make it on, right? So now when you press again, so now I have to make it off. Now when you press again, okay, I have to make it on, and so on. So what is the difference? I'm going to tell you what is the difference. The difference is unlike the case of switch, when I read the value of the port, it's not going to help me to know if the switch is connected or disconnected, on or off. It's not going to help me because all the time it is 5 volt, all the time, unless only when you press, right? So here it is 5 volt, but it has to be on because I turn it on here, right? Here it is off and 5 volt, but it has to be off, and so on. So how I hope you understand the difference between the two cases. This is number one. Before I explain how I can use the push button for on off. Okay. Again, just in one sentence, the difference is in case of a switch, you can if you want to know if it is on and off, that's very easy because we have two voltages 0 and 5. One voltage for one position and the other voltage for the other position. I can consider one position for on and the other position for off, right? And then all what I need to know, if you want to know if the system should be on or off, just check the pin. And that's what I did here actually in this program, right? But in case of a switch, it shouldn't be this way, right? Why it shouldn't be this way? Because the switch, as you see here, it's because the switch, once you press one time to make it on or off, it's going to return high again. So all the time it's high, right? So regardless of value of once you release. So now, so in this case, so in case of push button, how in this case, how can we how I can know if the system should be on and off? Okay, in this case, guys, what we are gonna do, I'm gonna use a variable. So there is a variable. Okay, this variable should have two values, any two values. For example, I'm going to use 0, 0 and FF. And later I'm going to explain to you why, or maybe just in a second, I'm going to explain why I use these two values. You can use any two values, right? So I'm going to assume, for example, one value like this one for on and this one for off, for example, right? So in the very beginning, so the variable should be, this variable should be FF because the system is off, right? Once you press the button here, I'm going to change the variable to 0, 0, right? So now it is 0, 0 here, right? Now, when you press again, so now it is FF. You press again, it is 0, 0. Very easy, right? So every time you press, I'm going to alternate this value from 0, 0 to FF, from FF to 0, 0, right? Why? Because one value, so this variable should capture or should capture my pulses. It should capture the pulses or the pressing your keystrokes, and it should actually and should reflect the status of the system. So at any time, if you want to know, should I turn the system on and off, just to see what is the value here. Is that 0, 0 or FF? That's it. You got what I'm saying? So now let's come to the, so again, you have a variable, also you alternate from one value to another, okay? So one for on and one for off, right? So now let's come to my question, why you told us we can use any values. That's true. So but also you told us you like these two variables. That's true. I like them. I'm going to tell you why I like these two values. Simply because it's easy to move from here to here or move from here to here. You know what? You know why it is easy? Because this one is a complement of this one, and this one is a complement of this one. You got what I'm saying? So in the code, it's gonna you just use complement. So it's gonna be easy. But you can use any other one. So now I'm gonna show a program. How can we do something like that? So I want to do the same thing as I did here, guys, but I'm going to use a push button in order to turn on and off the alarm. Is that okay? So I'm going to show it now. Yeah, here. So let's see here. The first part here is just configuration. This part is just a configuration. And actually, look here. So number one, here, I'm gonna check this the switch, right? If the switch is one means you didn't press it, right? So now it is one, means you did not press it, right? So that means I should not change the status of the switch, status of the system, Okay, that means I should not change the status of the variable. Here's the variable, we call it on off, right? Now, because it is high, what I'm gonna do, I'm gonna go to location called start. Start is here. Okay, here as you see, I'm gonna check the on off the variable. Okay, and then now if the variable tells me it is on, so I have to turn the buzzer on. If it is off, so I'm gonna go back. That's exactly. So look here, guys. So I'm gonna compare here. I'm gonna compare this variable. So when I come here, guys, means no change in the status, right? So all what I'm gonna do, because you didn't press, so there is no change. All what I'm gonna do is um, just I'm gonna check the variable to know if the system should be on and off, and then take action based on that. That's what I did. So if you see here, here I read the variable, I compare it to 0, right? If it is equal to 0, means it is off, right? So I have to come back to check again here, right? So 0 here, maybe in the example I explained before, I used 0 for off, for on. Please don't be confused. It doesn't matter, right? I have two values. It doesn't matter. One value for on, one value for off. So here I'm going to use 0 0 for off, and then I'm going to use if for on, right? Just two values. So now I'm going to compare this one to 0 0. If it is 0 0, just I'm going to come here to check again, right? But if it is not, so I'm going to come here. So that means if it is if I'm going to come here, and then you are going to run the police siren this way. Okay, because the system has to be on, and then I have to go to the beginning again to check again, right? So this is the first case, guys. The first case, when I check the switch, and you didn't press it, right? If you don't press the switch, so I have to come to here, guys, to check. I'm gonna ask the variable, so should the system be on or off? And then based on that, either I go up here and I don't run the buzzer, or I go down here to run the buzzer. If it is on, I have to go this way. If it is off, I have to come this way. Okay, now there is another way. Maybe I'm gonna come this way. Yes. Now if pH 0 is equal to 0, I'm gonna come this way. That means you press the button, right? So if you press the button, as I explained before, so as I said before, you have to move from one value to another. You have to change it. That's exactly what I did. If you see here, guys, so here I'm gonna load, I'm gonna read the value, I'm gonna read the switch, I'm gonna complement it, right? And then I'm gonna return it back, right? That's why I told you I like the value 0 0 if, because if you just use complement, you can easily alternate from here to here or from here to here. Okay, and that's what I did. And then here I can put the code for debouncing as well, right? And then after that, I'm gonna come here to check to see if the system on or off, right? If the system is off, I'm gonna come back here. If it is on, I'm gonna come back here. Okay, guys. Any question? I want to choose a video as well for this one. But first of all, I want you to understand. I spent some time on this part because I want you to understand it. You should understand what is the difference between a switch and push button, right? Especially if you want to use for something like on off, as I did here, right? For a switch, I told you here it is in one position it is 5 volt, in one position 0, one position 5 volt. So here I can take one position, I consider it on, and one position I consider it off. So if you want to know if you should turn the system on or off, okay, just check the voltage. What is the value of pH 0, right? If it is 1, for example, in this example means on, 0 means off, right? So that's why it is very easy, right? However, in case of push buttons, the story again is different, because every time you press, it's going to be low and high this way, right? So the voltage itself cannot tell you if it is on and off, right? That's why I should have a variable, right? This variable, every time I press, I'm gonna change. This variable should take one of two values, one for on and one for off, and every time I press, I have to alternate it, right? And then if I wanna decide should I turn the system on and off, I'm gonna ask the variable should tell me, right? So if you look at this program, guys, there are two things here. Number one, this part, right? Here I check if the system is on or off, right? This part here here, because you press, actually I change the status of the system, or status of the variable, right? So if the variable, if the system is on, I'm gonna make it off. If it is off, I'm gonna make it on. Okay, guys, any questions? Okay, so let me run the, yeah, let me choose a video first before we move to the next topic. Yeah, look here. Yes.
Now it works. It should be, if it works well, it should be when I press the button again, it should stop working. Let's see. Good. Look what happened now. Sometimes it's not smooth. Sometimes when I press button, it doesn't work. Look here. Doesn't.
Yeah, this is because I didn't put the debouncing code. You got what I'm saying? So when I press one time, so the program took it like I pressed it 3 times. So it actually became on, off, and on again, right? So I did nothing, right? So that's why I'm gonna put the debouncing code, and you will see it will be much better. But
Doesn't work. Doesn't work. Works. Look, it's not smooth. This is because of the bouncing problem. Now let's see if we. So here simply I add the deep bounce.
so now I'm gonna add the debouncing, and you will see by yourself how it is very smooth. So you will see every time you press is gonna be on and off. So because every time you press is gonna be taken only as one pulse. Okay.
Bouncing code. When I press, it works. When I press again, it works. However, the problem is that the program, it checks the status of this push button after 1 second. So
Yeah, that's why there was a delay in the beginning. It was not because of the switch, because as I explained before, we check the status every 1 second. So maybe after you press, it's gonna take some very a part of a second, right? Just to change the status. Okay, guys. So now I'm gonna move to the. We are very close to finish this chapter. Only I think just one main topic is left. So now I'm gonna move to the last topic here. This topic is about how can you convert the binary number to decimal, or decimal to binary. Okay. I'm gonna explain right now. Number one, why do you need to convert? Okay, and how. So I'm gonna explain this one right now. Okay, guys. Very important topic. Easy. It's not hard, but you should first understand why we need it. Okay. So look here, guys. In the first lecture of this course, we agreed that computers can only understand binary numbers, right, guys? So computer can only understand binary numbers. Okay. So if the microcontroller give you some value, for example, I did calculation, I did something, and the result, microcontroller is going to give you the result, right, of a certain operation, whatever your program is doing. So the result is going to give it to you in binary, right? For example, the microcontroller is going to give you something like 1 1 1 1 1 1 1 1, right? So if the result of a certain operation is 255, this is what the microcontroller is going to give you. We agree on that, right? So we agree on that from the first lecture. So what is the problem? The problem, human being don't like these ones. So now if the computer gives you this value, now I have LCD, right, for human, and there is a human here looking at the LCD, right? So, and that's what the computer should give me, right? This is binary number, right? So, in order to display it to human, right, I have to convert to decimal. So because human can only understand decimal, computers can only understand binary. So any result the computer should give it to you in binary. So you have to write a code. So I have to write here a code, guys. This code should convert. That's what I'm going to explain how this code is. But I'm explaining here why we need this code. So now you should convert the binary to decimal. Even that is not enough. You have to convert it to decimal and then to ASCII. But this is easy, right? And then to ASCII. So it's actually, but this is the easy part, converting decimal to ASCII, just easy, right? So, and then I'm gonna send everything to the LCD. So let me give you a specific example. If you have 1, 1, 1, 1, 1, 1, 1, 1, okay, guys? So number one, how can you convert binary to decimal? What it means? It means out of this binary number, I have to extract 3 digit, 2, 5, 5, right? So I have to extract 3 digit 255. Is that okay? So that's the meaning of binary to decimal conversion. Okay, how can you do that? I'm going to explain right now how can you do it. Very easy, very simple, right? So but I'm just explaining why you need it. So if you have this number and you want to display this number to a human, number one, you have to extract the digits from this number, right? This number one. Number two, you have to convert these digits to ASCII, right? Before you send them to the LCD. But this is easy part, because as I said before, in order to convert any number to ASCII, just add 30, right? So number 0 should be 30. Number 1 should be 31, all the way until number 9 should be 39, right? So this is just easy part, right? Is that okay? You understand, you guys? If you don't understand what I explain now, it's going to be difficult to understand what I'm going to explain next, because next I'm going to explain how can we do this. Is that okay? You understand the story now? Any question? Great. So now I'm going to focus only on this part, guys. If you look at this part, this is what I'm going to focus on right now, okay? Given binary number 111 as an example, what I have to run a code to extract the digit 255, right? What happens after that is very trivial. You just add 30, as I explained to you, right? You just add 30. So how can we do this conversion? I'm going to explain it to you right now. Look at the idea. The idea is, you have 255 guys, right? Binary for sure. 1, 1, 1, 1, 1, 1, 1. Is that okay? If I divide this number by 10, so now I'm going to have a quotient, which is 25, and then I have a remainder, which is 5, right? So this is the main idea. When you divide by 10, I'm going to get this digit here, right? So now I got 1 digit. I told you I have to extract it 1 by 1, digit by digit. Now I'm going to get the quotient again. I'm going to divide it by 10 again. Is that okay? When I divide by 10, now the quotient is 2, and now the remainder is 5. So now I got the second digit, right? So here, this is the first time you divide by 10, you are going to get this one. Next time you divide by 10, you get this one, and so on, right? Now you can also take this one, the quotient, you can divide it by 10, right? So now the quotient is 0 and the remainder is 2. Once you find the quotient is 0, you can stop dividing, because I'm done. You got what I'm saying? Very, very, very interesting idea. So this is how you can extract from any number, any value, right? So if you have any number here, you have to divide by 10, as you see here. I'm going to divide this number by 10, and then I'm going to get 1 digit. I'm going to get the quotient divided by 10 to get 1 digit, and I'm going to continue this way. Every time you divide by 10, you are going to get 1 digit, right to left. So I get them right to left. Be careful about this, right? So that means when you display them, you have to display left to right, right? Because otherwise, so here you are going to get 5, 5, 2. But when you display, I have to display 2. So I'm going to get them this way, right? Right to left. But when you display, I have to display 2 to 5, right? Or 2, 5. Otherwise, if you don't do that, you are going to get 5, 5, 2, which is not true. Okay, guys? Is the idea clear, guys? Any question? Okay, so all what I need is, how can you divide by 10? How can you get quotient and remainder? In assembly, that's very trivial, right? Because this is the way division instruction instructions work in assembly. Every time you do division operation, actually you get remainder and you get quotient. So you're gonna get it right away. However, how can you do it in C language? In C language, you guys, if you use percent, this one gives you the remainder, right? But if you wanna get the quotient, you can use this one to get the quotient, right? But the result you have to store it in integer, as you will see right now. So if I say 255 divided by 10, right, this way in C language, right, and you store the result in here in an integer variable, so you are gonna get 25 here, okay, which is correct. But if I say 255 percent 10, so this one is gonna give me 5, right, the remainder, right. So you have to use these two operators to get the remainder and the quotient in C language. Okay. So now I'm going to show you. This is the first part. Is how can you convert binary to decimal? So I'm going to show you now. Yeah. Sorry, just 1 second, guys. Hello. Okay, guys, I'm sorry for that. So now, if you look here, okay. So that's nothing here is new. This is exactly what I explained. This is also the same thing what I explained. If you have a number, you have to divide by 10, you get the quotient, and then you get the remainder. This is exactly what I said. Also, you are gonna get them, the numbers you are gonna get here, the least significant first. So you are gonna get them right to left, right? But you have to be careful when you send them. For sure, after you get them, you have to add 30. You have to add 30 to convert every one of them to Ascii, right? But also when you send them to the LCD, you have to send them from the last one first, right? The most significant first, or I'm right or wrong? Yeah, should be this one first, right? One and then two, because the LCD is writing left to right, right? But we're gonna get them right to left, right? So here, that's exactly what I said. You divide by 10, you are gonna get quotient, you divide it by 10 again, and so on, this way, until it is 1. Once the quotient is 1, we stop and, okay. So now, I'm giving you here one example. How can we do that? So here, I'm asking you to write a program to convert 16-bit number stored in register G and the decimal numbers you are gonna get. I asked you to put them in this memory location this way. So you can see the way I did it here. So here I put 10 in register X, right? And then I do IDIV, because when you do IDIV, guys, you divide register G by 10 by X, right? And then once you do that, the remainder has to go to register G, right? But actually, because you are dividing by 10, just give me 1 second. Yeah. So here, this is how this instruction is working. So this instruction, the remainder is stored in 16-bit, which is register G, right? However, because the remainder should be less than 10, okay? So actually, it's going to be only in register B, right? You know, register D is 2 parts, B and A, right? But because this number is small, so 1 byte should be enough. But again, I cannot change this instruction. This instruction automatically store everything in in a word. So that means I can just take this part and just ignore this part because it's going to be 0 all the time in this case, because I divide by 10. And that's what I did. So what I did here, guys, I took register B, I put it in the location 4 comma y here, because I want to put this one here, right? And so now I got one digit. So now the quotient is in register X. Okay. So as I told you before, so now the quotient is in register X. As I told you before, now we are going to divide this quotient by 10 again, right? So how can we do that? So this quotient has to go to register G, because this is how this instruction is working. This instruction has to divide register G. That's what I did. So here what I did exchange instruction, because I want to register D to have the quotient, because I'm going to divide it by 10 now. And that's what I did. So now I put 10 in X, and I repeat again, divide again to get another digit. And this digit again, it is in register B. I'm going to put in 3 comma Y, right? And then exchange again in order to put the quotient in G to divide again, and so on. So I'm going to continue this way until I am done. Okay, guys, any questions? Easy, right? So any question, guys? Great. Okay, now how can we do the same thing in C language? Okay, in C language, you guys, you have two options. Okay, one option, you can use a function. So I'm going to explain a function, right? So you can use it. The other option is you can do similar to what I did here in assembly, right? And I'm going to give you a reason why some students decided to do that, because if you have a function is working, so why I bother myself and do something like that, right? So but I'm going to give you a reason for that. But you can do the same thing. And as I told you guys, in this case, if you want to get remainder, you have to use percent. If you want to get quotient, you have to use the division or the slash. Okay, so now also I'm going to explain. Now we have some functions. Okay, so the first function I'm going to teach now, look here, we have this one, guys, write integer to LCD. Very interesting function. So this function, you put here integer to this function. This function is gonna, number one, convert the integer here to decimal. This number one. Number two, convert the decimal digits to ASCII. Number three is going to write the ASCII to the LCD. Very interesting. Why? Because this function is going to do everything, right? Let me say it again. So this function, guys, just to put a number here, give it a number. For example, if this is an integer here, right? And the integer is actually 16-bit. So anyway, this is an integer. So and if I put a certain value here, and then I set, as I said last time, we set the LCD so that I want to start writing from location number 0, and then I'm gonna call this one. I'm done. I already displayed. So now after I do this one, if you look at the LCD, you will find this one, right? Very interesting. So this function, and this is why some people like C, or sometimes people like functions, because this function is too complicated. This function is doing a lot of things, but in programming it should be very easy, because again, this function, number one, I'm gonna put here integer. This function is gonna convert the integer to decimal, right? It's number one. Number two, it's gonna convert the digits, the decimal digit, to ASCII. Number three is gonna display on the LCD, right? So you can do this way very easy. So we have two of them. One is called write integer to LCD. This one. We have another one, write long to LCD. Okay, what is the difference between them? They are exactly the same, but this one is for integer. When you wanna, if your number is integer, this one is your number is long. The second one here is if your number is long, right? What is the difference between them? In case of long, it's actually 32-bit integer, but if your variable is integer, it's going to be 16-bit. So if you have a bigger number, you can use this one here. Okay, so I'm okay. You can use this one all the time. It's okay. However, some students, as I told you before, they in C language, they did this one. I'm going to tell you why. Because this function has a little problem. You know what's the problem in this function? I'm going to tell you. So this function here, is an integer function here, guys. So this one is gonna display 5 spots, 1, 2, 3, 5 spots, 1, 2, 3, 4, 5 spots, no matter no matter how big is your number, right? So you know, if the number is 16-bit, guys, it can go up to 65, 535, right? So what if my number is only, for example, 72, right? So what's going to happen is going to display 72, and then it's going to be spaces here, right? So some students didn't like that, to have like some spaces here, especially if you put this one in a sentence. So for example, you can say the temperature is, and then you leave some space and you say, for example, 72. Maybe some students didn't like this one, and in this case, again, I'm okay. I'm not saying you have to. I'm just make it easy. Just use this function. I'm happy. Even if you leave a space, that's okay. As long as it works, this is just a minor thing. But again, I told you many times, as any instructor, I should teach you different ways. Okay, maybe in some programming problems, you may not like this one. Me you like this one more, okay? But anyway, so again, what I want to say, conclusion is, in C language, you can just use this function, guys, or you can use the same thing I did here, okay? This is the end of the first part. Is about any question, guys, please. So now I told you, you have a binary number. How can you display this binary number to the LCD? I told you the first step, you have to extract the decimal digit by dividing by 10, as I explained here. And then once you get this digit, you have to convert this digit to ASCII, and that's the easy part. You just add 30. This is the easy part. So if you add 30, 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 you actually convert every digit here to ASCII, right? And then after that, you send it to the LCD. This is the easy part, right? So any question, guys? Okay. Now, so what I explained now, I told you this is what we call binary to decimal conversion, right? So I had a binary number, and now I've converted to decimal. Is that okay? Now, what I'm going to explain right now, the opposite. What if you have digit, right, coming from the keypad? How can you convert it to binary, right? Because I told you, only microcontroller can understand binary. It's like you are a translator, right? This guy can only understand binary. Human can only understand decimal, right? So if I go this way, I have to convert the binary to decimal, right? However, if I go this way, I have to do something else. I have to convert decimal to binary. So that's what I'm going to explain right now, okay? How can you do it? So look here, guys, what I want to say. Last time I explained the keypad, right? The keypad. If you ask the user to enter a number, okay? 3-digit number. You are going to use this number later for something, right? So you just want to get the number from the user, give it to the program, so that the program is going to do something based on this number, right? So here, what I'm going to do, for example, I'm going to hit number 2. So here, you are going to get 32, and then you are going to get 35, and then you are going to get 35, right? This is what the human is going to give me. This is what the keypad is going to give me, right? So now, so what the number you want to use is 255. So you press 2 first, right? You press, after that you press 5, after that you press 5, right? So actually, so now the keypad is going to give you 32, 35, 35, right? So now you have these 3, okay? So now I want to send this number to the microcontroller, okay? So now I have to convert, decimal to binary, right? So I have to convert it so that I have 1, 1, 1, 1, 1, 1, 1. Again, I'm just giving example on 1, 1, 1 because it's just an easy number, but this idea still can work for any other number, right? If it is 172, 122, any other number can work. I'm just using the number I just memorize, 1, 1, 1, 1. Okay, it's an easy one, right? Anyway, guys. So first of all, there's something very easy you can do right now. What is this? Number 1, this number is ASCII, right? This is ASCII. Can you convert ASCII to decimal? Yeah, that's very, very trivial, right? All what you have to do, you have to subtract 30, right? So if I subtract 30, now I have 2, now I have 5, right? 255. Now I'm going to use 255 in order to convert this decimal to binary. I'm going to tell you how. Okay, guys, any question? Okay. Look here, guys. If I have 2 and 5 and 5, right? Okay. Now, how I can convert this one to 255 or 1111? Okay. So I want you to go back very far to second grade or the third grade. This was a question in the second grade or third grade, by the way. They give you this number and then they ask you to make the number, right? They told you, listen to me, they told you this is in the ones. So the weight of this one is in ones. And this one is in the tens. So the weight of this one in tens, right? And this one is in 100. So the weight of this one is in 100. Is that right? So what I can do, very easy. So I'm going to take this one, guys. I'm going to multiply it by 100. Then I'm going to add 5 multiplied by 10. Then I'm going to add 5 multiplied by 1. Because it's 1, you don't need to do that. You don't need to multiply. But anyway, I'm just try every digit multiplied by its weight. So if you do this calculation, you're going to get 255. Is that okay, guys? So this is very easy to do. Very easy to do it. Just to multiply every number by the weight, add everything together. You are going to get 255 as a binary number. Is that okay? However, sometimes, so I'm going to show how can you do that. But sometimes there is another way. Sometimes I'm going to get from the user digit by digit. So sometimes every time, so there are two ideas here, guys. Number one, I can get all the digits this way and then convert everything right from the user. So the user give me 255, and then after I'm done receiving all the digits from the user, now I'm gonna run it to get to 255, right? There is another idea that I can make something like running binary number, right? Okay, what it means, I'm going to tell you what it means. So the user first give you 32, right? The user hit 32. So in this case, and here, this is my running decimal number, binary number, right? So now it's 32. So now it's easy to make it 2. You just subtract 30 as I explained. And in the very beginning, my running number is 2. Is that okay? So you enter 2. Now my running number is 2, right? And then look here, the user entered 35. Is that okay? And now I'm gonna subtract 30, so I'm gonna get here 5, right? So now how I'm gonna merge this 5 with this 2 in order to get 25. Because so far it is 25. The user give me 2 and then 5, right? So what I'm gonna do, I'm gonna take the old value, I'm gonna multiply it by 10, right? Because actually what happened, when you enter 2 in the beginning, 2 was in the ones, right? When you enter 5, so now 2 has to move to the tens and 5 has to move to the ones. So now, then I'm gonna add 5. By this way, you are gonna get 25. Makes sense, guys? After that, the user enter another 35. Okay, again subtract, it becomes 5. So now I'm gonna get this one, I'm gonna multiply it by 10. So 25 times 10. You know what? Think about it. You know what I did when I multiplied by 10? Actually, this 2, I moved it. So this one you should get 250, right? Because this 2, I moved the 2 from tens to 100. And then I moved the 5 from ones to tens, okay? And then I can add 5 to get 255. So by this way, you can make it running, right? Sometimes this is easy way, especially if you don't know how many digits the user can enter. You got what I'm saying? Sometimes the user is going to enter. You can ask the user enter up to 65,000, for example. So the user can only input 2 digits. It can be 3, it can be 4. So sometimes this can make the program easier. Every time I get a value, I can make something like a running binary this way. Okay. Again, quickly. In the first one, the number I'm gonna get, this is the running binary number will be the same. Every time, so the idea is that every time I get another digit, I'm gonna multiply this running by 10, so that I shift this one, right? One step by multiplying by 10. This one was in the ones. Now it became in the tens, and then I add 5, so I'm going to get 25. So you can see this is a running, right? This is a running binary number. Now you give me 3, right? So I'm going to multiply this one by 10 and add 5, I'm going to get 255, and so on. So it's going to work for any number, for any numbers of digit, any number of digits you enter. So I'm going to show now how can you do something like that in both in C and assembly. So this is that's what I said. We need to convert the decimal number to binary, as I explained this way, right? So this is the idea, guys. Once I get the first number, right? The first number, once I get the second one, I'm gonna multiply it by 10, and then I add the second number, right? So that's exactly what I explained. So also, once I multiply it by 10, and then I add another one. So every time I get one number, here, this is the operation. This is operation 1, operation 2. If I do that, if you look here, what happened, you will find N1, I multiply it by 10,000, right? N2 is multiplied by 1,000, the weight of these ones, okay? So anyway, so I'm showing you this program here. I'm telling you in this program, you have 5 digits. These 5 digits are already in the location 10, 10, and 10, 14. So I want to convert this 1, 2, 3, 4, 5. So I want to convert this number to binary. So what I'm gonna do, guys, is first here, this is I'm gonna start. This is also important to understand. I have to start from the most significant first. So this one is the most significant, right? So here I'm gonna take this one. I'm gonna put, as you see here. So I'm gonna take this one at 10, 10. I'm gonna put it in register A, right? And then I'm gonna put 10 in register B, and then I'm gonna do the multiply, right? Once you multiply, so now I got the first number, I multiplied by 10. Now I have to add next number. Okay, that's what I'm gonna do right now. Okay, so what I'm gonna do right now, I got the second number at 10, 11, as you see here, right? I'm gonna put it in because here the result you are gonna get in a word, right? So also I want to add word to a word. As you see here, guys, the running, running binary number, I store it in 2000 a word, right? So once I get a digit here, guys, I have to convert it to a word, right? In order to add word plus word, right? That's what I did here. Okay, so here I got this one, put it in register B, and then I have to put 0 in register A. So that these two instructions together, I'm gonna get a word, right? In register G, and then I'm gonna add this word to the running. Again, 2000 is the running binary number, right? So now I got a number N2, right? And I added it. Now I'm gonna get now I want to add one more number. So again, I have to multiply by 10. So this time I'm gonna use emal, because now I have word and word, right? So I cannot use mul. I use mul before because here I in the very beginning I can multiply by 10 by a number, right? But now I can it's word and word, right? So here I'm gonna put 10 in y, and then I'm gonna say emal, right? To multiply y by g. So by yg. So here the running I put it in G, so you can multiply it by Y, and now the result is going to be stored in Y and G. We assume that or in the specifically in this case, because I have only 5 digits. Okay, this is a very small thing, but I know some students are confused here. Look here, guys. 1, 2, 3, 4, 5. So it's a 4 digit, a 5 digit. So if I assume these 5 digits are not more than 65,535, that means a word should be enough. So even if the result, also the result here is in 32-bit, but actually I'm assuming my number is only in G, right? Because it's a small, it shouldn't be more than a word, right? So anyway, so here again, this is the running, I can put it in 2000, and then after that, I'm gonna repeat again. So now I'm gonna get the next number, as you see here. I'm gonna make it a word. I'm gonna add it to 2000. So now that's exactly what I did now. So I got 3 number, N1, N2, N3, right? So I'm gonna continue the same way. So I'm again, just repeat. I'm gonna multiply by 10 here. In this part, I'm gonna multiply by 10, and then add another number, and so on. So every time I got one digit, I multiply the running binary number by 10, I add the new digit, and so on. Okay, guys, any questions? Okay, for let me for for um, for C, how can you do the same thing in C? So it's very easy. Number one, in C, you can do the same way I explained right now. So you can just multiply by 10 and add. You can do the same thing. Also, in C, we have a function. You can just use this function. I want to explain it now. So this function, we have function called number. This is the name of the function, number. This function is going to take array of characters, right? Every character here is ASCII. So here, and then this one is going to return a number. Let me see here. So here, so I have array of ASCII numbers. For example, let me just to clarify what I want to say. For example, if you have guys 32, 33, or 35, 35. So this is array, right? 32, 35, 35. So I'm going to send this array here. I'm going to put it here. This is just the name of the array. I'm going to make a pointer, right? So you just send this array here. Once you send this array, this one is going to return 255. Is that okay? Okay. So now you can do that. Also, I have here a number of functions. In addition to what I explained, I also created a number of functions you can just use if this can make everything easy for you. So here we have here this subroutine, guys. This one is called decimal to binary, 8-bit unsigned. We have another one, decimal to binary, 8-bit signed. This is for assembly, by the way, guys. So I just, again, I'm explaining different ways. If you want to do what I explained before, that's okay, right? But also I have some functions that you can just use. So here this function is called, this is decimal to binary, right? Decimal to binary, but this one for 8 bits, and this is if the number is signed, and this is for signed. Same thing here, this is for 16 bits, signed and unsigned. So now I'm going to explain how can we use these functions, right? This can make the programming easier. So now here I'm saying, so here the decimal number is stored as ASCII in an array, and this array should end by 0. Okay, and then you have to send the array to this function. This function should do the conversion. So let me explain what I want to say here, guys. I'll clarify what I want to say. What I want to say is, for example, you have array like 32, 35, and then 35, right? So we have an array this way. Okay, guys? This is the beginning address of the array. You have to make sure you have to put 0 at the end because this is a delimiter, right? You have to do that. Once you have array like this one, I can send this array to one of this function to do the conversion. Is that okay? And then these two functions are gonna store the binary number in register B, right? But these two are gonna store the binary number in register D, right? So, and this is the return. So this is the return of these two functions, right? Very easy. So this can just make easy. You don't need to multiply by 10, as I said before. You can just use this function in assembly. Can make it even more easier, right? And then, but how I can send this array to this function? All what I have to do, I have to send the beginning, and you have to put the beginning address. You have to put it in register Y before you call these functions, right? So let me say it again, guys. So again, in addition to what I explained before, you can just use some functions in or subroutines in assembly. In these subroutines, you can give like array. As I told you, this array should have digit like 32, 35, 35, and so on. And then you have to put delimiter 0 at the end. And then before you call any of this function, you have to store the beginning address in register Y. So this function, what this function is going to do, but they have to be in ASCII again, guys. Okay. So this one is going to convert the ASCII to decimal, and then it's going to convert the decimal to binary, right? So this one is going to do the conversion until it finds 0, and then it's going to store the return value or the result in B in case of a byte, or in D in case of a word, right? Here also I'm telling you, if your number is negative, so the first element here has to be the ASCII of minus. So if it is negative. Okay, any question, guys? Again, if you already confused what I'm saying, guys, I'm not teaching anything new. I'm saying what I explained before here, if you are okay with that, you can do it. See here for when you convert decimal, yeah, this one. So here you can use it. I'm totally fine. Or maybe there's also another easier way. Just you can use this function as I explained. Okay. So now I'm gonna show you another. I'm gonna show a program now. Um, Also, I think we have also, sorry, this is for, yeah, I forgot to say this part, sorry. So we have here we have four function, guys. This one should do the conversion from decimal to binary. So you have to put the decimal in array this way, guys, right? And then you have to send it to the function by putting the beginning address and register Y, and then this one should return in B or G, right? So we have another functions, they can do the opposite, binary to decimal. That means, so I just want to make it easy. Look here, guys, what I want to say. Okay, so this function is going to convert from here to here, right? So you are going to give this array to the function. The function is going to give you a number here, right? But what I'm saying, we have another function. It can go the other way from here to here. Okay, this is binary to decimal. So the other function, this for function, guys. Okay, so you should give binary number, and then this will produce an array like this one, right? So now I'm going to explain how can we use it. Okay, so that's why this one is called binary to decimal. Again, I'm saying, guys, nothing is new. I just want to make, I already explained how this conversion binary to decimal or decimal to binary, how it works. I just wanna I just wanna make another easier way to do that. Okay. Okay, guys. So now I want to explain how can we use these functions. Number one, if you want to convert 8 bits, you have to put the number you want to convert in register B. So this is your input. Remember, this was the output here, the result, return, right? But here, this is the input. And also here, you have to put the input in register G. Is that okay, guys? This is number one. Number two, this one is going to convert this one to an array, as I said, and it's going to put 0 at the end, right? But where is the beginning address? Where it has to put it? You have to tell, right? So that's why you, before you call this function, you have to put the beginning address in Y. So you have to put the empty array, or where you want to store the result. You have to put it in register Y before you call this function. So this function is gonna store the result starting from Y, right? So let me summarize what I said, guys, quickly. These functions here, this function is going to take an array like this one. All what you have to do, just put the beginning array, put the beginning of the array in register Y, right? And then call this function. This function is going to convert this one to binary and store the result in B or G. B in the case of these two functions, G in case of these two functions, right? Here we are going to do the opposite, right? Here you have a binary number B, and so and then all you have to give me the beginning address where you want to store the result. So you have to put it beginning address in Y before you call this function. Also the number you want to convert, put it in B and G before you call the function, and then the function will produce this one here. Okay, guys, any question? I want to tell you something very interesting. You may not notice yet. Last time I explained, this is the beauty. This is the beauty of functions, right, guys? Function can make programming easier because any complex thing, you can just put it in a function and you can just use it, right? If you remember this, I told you about this array this way. If you have array of Ascii codes, 0 at the end, right? I explained last time in the LCD, I explained to put a string to LCD. Put a string to LCD, right? I told you this function is going to take an array like this one, right? Just that means what it means. It means the format of the output of this array is compatible with this array, right? So I can take, so I have, if I have a number in register B, right? I can use this function to convert it to Ascii, right, to ASCII, and then at the end 0, and then I can take the output of this function, I can send it to this function directly. So I made it this way. I made the output of this function compatible with this one, because this one, in order to work, you have to put 0 at the end. There is only little difference. Maybe I didn't pay attention to it, but that's not okay. It's not a big deal. The only difference here, in order to give the beginning address here in this for function and this for function, you have to put the beginning address in register Y, okay, before you call them. However, if you remember from last time, put a string to LCD, you have to put the beginning address in register X, not Y. Okay. So now I wanna also explain here a program. It is called get number. Okay, so I'm gonna tell you how this program is different from what I taught before, and very easy. Um, Look here, guys. What I did before, I explained before keypad, right? I explained keypad. I told you keypad is gonna give you only one keystroke, right? And I told you it's gonna give you only one number. So if you call keypad, you are gonna get only one number. What if I wanna get like a pin code? What if I want to get from the user more than one number? For example, 372, whatever, any number, right? So I told you I have to use keypad multiple times, and that's exactly what I'm going to do in this function. This function is called get number. Well, and you can just use this function. I told you in the exams. You can use any function. I explained here in the course. You don't need to write it, right? Just use it, right? So now, so what is the difference between keypad I explained before and get number? Get keypad is going to give you only one digit, right? Get number is going to give you like an array similar to the array I explained right now, 32, 72, 35, 35, and it's going to put you 0 at the end. So get number is going to get a number from the user, and then it's going to store it in this format, so that, very interesting. So I made it compatible. So the output of this function is actually compatible with both string LCD. So once you have this function, you can once you call this function, you are gonna get multi-digit number from the user and store it in this format, so that I can send it to both string LCD if you want to display it, or I can send it to this function decimal to binary if you want to convert it to binary. Very interesting. You got what I'm saying? Um, just think about it. Just focus with me, and it's very interesting, very easy, because the output is a function. I just sent it to another function to do a lot of things. So let me summarize what I said, guys. This function, I'm going to explain how it works. You will find it's just very easy. Once you call this function, you are going to get more than one digit from the user. For example, the user enter 323535, and then the user hit enter. So hit enter means I'm done, right? So you are going to create a function this way, right? And then once you have this function, as I told you, you can simply send it to both string LCD, right? So that you can display it on the LCD, or you can send it decimal to binary to convert it to binary. Just very easy. If you know how to use it, very easy, right? So now I'm going to explain how this function works. So all what you have to do, guys, here in this function, here, before you call this function, you have to put in register Y the beginning address of the array, right? So again, this function is going to get multiple digit from the user, and it's going to store it in array. So I have to put the beginning address of the array in register Y, like 32, 37, 30, whatever, 5, and then 0, and it's going to put 0 at the end, right? So here, as you see here, I'm going to tell you how it works. So the idea is that inside this function, I'm going to keep calling keypad until you hit enter. So this is enter here. So here I'm going to use this symbol for negative. I'm going to use this symbol for enter. So okay, so what's going to happen? I'm going to start from Y. Every time you give me a digit, I'm going to put ASCII, and once you hit enter, I'm going to put 0, and then I'm going to leave. That's it. You got what I'm saying? So anyway, so I'm going to show you how it works. Very simple. And again, after I explain it, you can just use it. So now you have keypad if you want to get only one digit from the user. You have get number if you want to get more than one digit. So I'm going to show how it works. Number one, guys, as you see here, I'm going to call keypad, as you see here. Okay. Then I'm going to compare it to asterisk. So asterisk here, to me, it means negative. So if this one is negative, I'm gonna come here. Look what I'm gonna do. If so, I'm gonna put the ASCII of I'm gonna put the ASCII of negative in the memory location pointed by y and increment y. So you give me here. So I'm gonna put the ASCII of negative and then increment y and then go get another digit, right? So this is if you hit asterisk. If you hit bound, if you hit this hashtag or bound sign, so that means you are done. Okay, why I did this way? Because maybe you only enter 2 digit, right? And then you hit enter. Maybe you enter 3, maybe you enter 4, maybe you enter 5. So sometimes it's variable, right? So I'm gonna keep receiving number from you until you hit enter, right? So here, then if it is not negative, so I'm gonna come this way. I'm gonna check if it is enter. If it is enter, that means I'm done. Look here. If I'm done, I'm gonna come here to put 0 in the location pointed by y, and then I'm gonna leave, right? If not, so if it is not negative, if it is not enter, what should I do? Okay, what should I do? I have to put it here in the array. But before I put it in the array, I want to check you enter the correct number. Any number, correct number you entered it should have ASCII from 30 to 39. This is the range of the ASCII between 30 and 39, and that's what I did. If you look here, okay, here I'm gonna compare. Just let me. Yeah. So again, if it is negative, I'm gonna go this way. This is if it is negative. If it is enter, I'm gonna come this way, right? Enter. If it is not negative, it's if it is neither negative nor enter, so I'm gonna come this way. Now I want to check if it is a valid number. Valid number means it's between 30 and 39. I'm gonna put it in the array. Otherwise, I'm gonna discard it, and that's what I did. Look here, guys. I'm gonna compare the number to 30. Number 30. If it is less than 30, so if it is less than 30, that means this is not a correct number, right? So I'm gonna ignore it, and that just to go back and get another number. I'm not gonna put it in the array. I'm gonna ignore it, right? Same thing if it is greater than 39. That's what I did. Look here, guys. Now I'm gonna compare with 39. If it is greater, same thing. I'm gonna also ignore. I'm gonna come here. If I come here, what it means? It means it is between 30 and 39. So it is a valid number. So this valid number, I'm gonna put it in the array and then go get another number again. Okay, guys, is that clear? Any question? Any question, guys? Okay, so we're very close to finish this chapter, but so now I'm going to show a program right now, guys. This program you will see in this program. It is interesting because I'm gonna extensively I'm gonna use functions. You will see how the output is one function. I'm gonna use it input to another function and so on, right? So you will see right now. So I want to receive 2 numbers from the user using get number. I want to add them, right? This is a very simple program in any. So I want to get 2 number. Every number is multiple digits, right? And I want to convert them to binary. Then I'm gonna add binary plus binary. And then the result I'm going to get it in binary. I'm going to convert to ASCII and display it on the LCD, right? So let's see how can I do it. So here, number 1, I created array of 5-digit array. So this is the array. Any number I receive, I'm going to put it here in this array, right? I'm assuming you should not have, or I'm asking the user not to input more than 5-digit, okay? So let's see how it works, guys. Number 1, I'm going to put the beginning address of this array in register Y, and then I'm going to call this function. Very easy, very simple, very easy. So what this function is going to do, guys, this function is going to take a number from the user, okay, and then it's going to store it in this array, which is pointed by Y. So it's going to store it in this array, right, in ASCII, okay. So now I got 1 number, okay. So now here what I do here, I just clear the LCD, right? And then now I want to display this number. For example, you enter 30, 32, 35, 30, 35, okay? So I want to display this number on the LCD. So, okay, so I want to display 255, okay? How can you do that? Look how it is beautiful. Look how it is easy, because the output of this function here is compatible with both string LCD, okay, guys? So now I'm gonna send this one to boot string LCD. How can you do that? I told you there's just a little difference here. For boot string LCD, you have to put the beginning address in register X, right? So here I'm gonna just put the beginning address and register X. I'm gonna put a string LCD. So this function actually is gonna display this number on the LCD. Is that okay? Now, so now I got a number from you. It's like, for example, for just an example, you enter 37, and I already displayed 37. Okay, what should I do next? Okay, what I do next, I have to convert this number to a binary, right? Because I want to add when I do later, I have to add binary plus binary. So I have to convert this one to binary. So how can you convert this number to binary? You will see again, very easy way. I'm going to use this function here, right? So this function again, I'm going to send this array to this function, right? This function is going to do the conversion and convert it to a binary, right? Very easy. So once I finish this function, uh, here again, I'm assuming it is the number is 8-bit. Okay, so here I'm gonna once I get the number, so now I got the first number. So the first number I'm gonna store it. Sorry, I'm gonna store it. So now so now I got the first number, so I'm gonna store it in a memory location called number. So I got the first one. Now I'm gonna repeat the same thing again in order to get the second number. Okay. So anyway, also I'm gonna display now plus. So now the user entered 37. So I'm gonna add plus, right? And then I'm gonna repeat what I explained before to get the second number. So now I'm gonna get second number from the user. I'm gonna display it on the LCD. So I'm gonna display the second number as well here, and then I'm gonna make equal. Right? And also I'm gonna convert this number again. Just very interesting because I take one array, input it to one subroutine. Okay, so now I converted this one to a binary number. So now I have two binary number, guys. One is stored in the memory location binary. I did it here. So one is stored here. The other one here, after this conversion, it is stored in register B. So now I'm going to add the two binary numbers together. Okay. So now I got two numbers from the user. I added the two numbers together. Now the result is in binary, right? Right. So now I want to display the result. I want to display the result to the users, right? So I have to convert this binary to binary to decimal. And again, here I'm going to just use a simple function. This function, it is here, guys, very easy. So here, what I'm going to do, the result is in register B, right? So I'm going to call this function. This function is going to convert the result, which is in binary in register B, is going to convert it to array, right? And it's going to store it starting from this location. So this is the result in Ascii, right? And then I'm going to send this one to boot string LCD, right? So very easy. So these functions made everything very easy. So now I got two numbers and I added them together. Let me just one second. Maybe I want to choose a video quickly just to finish this one. Uh, adding. So now look, guys, I'm gonna input a number now, right? Once I input the number, so it's gonna be shown here. There's still nothing here. I'm gonna input a number. Yeah, it's 11. So once I input 11 and then it's added plus, now I'm gonna input another number, right? Yeah, so now it is 22, right? And then give you the result. Let me go back, sorry. Every time you enter a number, you have to hit enter, right? Yeah. So as you see here, two numbers added to this. Okay, guys. So thanks, guys.